In this video, I'm going to explain how to easily look into the compile results from the C source code. So here is a website that is called gotbolt or Compiler Explorer, gotbolt.org. And in this website, you can insert your C program. You can save it and or load it from your uh, computer, and you can write it on online here. For example, I'm writing a main function that is just returning a 0 here. Okay, so far so good. And it at the right hand side of this view, it is going to emit the result of the compiler. And here I'm using the Clang compiler with this option that is, let's please write down the LLVM-IR instead of the assembly. So from this code, it is generating the corresponding LLVM-IR here. So this main function is located here, and it is a function that is returning I32. That is the LLVM name of this int. That is the 32-bit integer. It is first creating a local variable. So this is a local variable allocation, which we are going to deal with later. But let's think of it as just a memory allocation. And it is storing a value 0 here to local variable here. And then it is returning 0. It is very simple code. And foo is also simple. Foo is also a function. This is due to the name mangling. And it is allocating, storing, calling a function, blah, 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 and calling blah, blah, blah. So this, you can hover your mouse and see what kind of C program or C statement is generated into which area of code in this LLVM-IR. You can change the option like this. If you want to give an optimization option, -01, then the code will be much simpler. It is removing all the allocations, for example, and just calling the function instead of storing a value to memory allocation, blah, blah. And if you want to see the x86 assembly, then it is going to show you the assembly here. And this is the result for the x86 assembly without any optimization flags. So it is very convenient to use this tool when you're going to target on writing a compiler, because you can immediately see the expected output of a compiler that you want to build. So please use this tool. There are many other options as well, but I recommend you to use this Clang, x86 Clang, and with or without the option to write the LLVM-IR or not. So there are 4 possibilities, 4 options that is useful for you. With LLVM-IR or not, and with optimization or not. So please use this tool for your homework. There is also RISC-V target that is going to be used in the later part of the course. So, for example, it is compiling this code into a RISC-V assembly, which looks like this. So the meaning of this assembly will be discussed in a later stage of this course. But yeah, this code is compiled to this. So you can easily see what is the expected assembly code you're going to generate from a code. For example, you want to see what is the add operation for float numbers, then You may use this kind of things. Oh, there is some error. What is the error? Oh, here we're reusing. See here. Oh, yeah, like this. So we are going to this code is oh, this is too much. So it is a simple function that is adding two float numbers. Then this addition is translated into these three lines from line 4 to line 6. And you can immediately see that, oh, this f@s should be the instruction that adds two float numbers into ft0, for example. And yeah, so by looking at such a translation results from this Compile Explorer, you can adequately select the instruction for your homework at the later stage of the homework. So the key idea or takeaway wisdom is that please use this tool to see what's the expected behavior your compiler for IR, both for IR and for the RISC-V assembly.